Welcome to our podcast, where today we're diving into the fascinating world of audio processing, specifically focusing on a unique tool called triforce. This is a beamformer designed for Apple Silicon laptops, and it aims to enhance the audio experience by effectively managing the microphone array found in devices like the MacBook Pro and MacBook Air. So what's a beamformer exactly? Well, think of it like a tool that helps focus on a specific sound while minimizing background noise. Imagine you're at a crowded cafe trying to have a conversation. A beamformer works to amplify your voice while dampening the sounds of chattering patrons and clinking cups. That's the essence of what Triforce aims to achieve. Now, why do we need this? The microphone arrays in these Apple laptops, arranged either in a triangle or a straight line, are designed to capture sound from all directions. This can be especially challenging because, without some form of noise cancellation or directionality, the microphones can pick up too much ambient sound. It's like trying to listen to your friend while a band plays loudly in the background. So, Triforce implements a minimum variance distortionless response, or MVDR, to refine what it hears. It's interesting to note that while we often think of sophisticated technology as being always on the cutting edge, Triforce keeps its dependencies minimal. It only requires a library for LV2, which might sound technical, but it essentially helps the software interface with audio plugins more effectively. And isn't it refreshing to see a project that values simplicity in an age where complexity often reigns supreme? But let's dive a bit deeper. The developers behind Triforce have acknowledged that finding good literature on digital signal processing, or DSP, can be a bit like hunting for a needle in a haystack. The complexity of topics like wideband adaptive beamforming can be daunting, and the creators have openly shared that their understanding comes from a mix of undergraduate engineering concepts and online research. So, while Triforce is an impressive project, it does come with some caveats. For example, it doesn't yet outperform Apple's built-in functionality. Improvement is something the team welcomes, inviting patches and contributions from the community. Another notable element is the current performance limitations. The software relies on mathematical routines that aren't optimized for speed, which means that real-time audio processing can sometimes be sluggish. It's a fascinating conundrum. While we aspire for efficiency and real-time capabilities, there's a balance to strike between advanced functionalities and the computational power required to support them. So what does this mean for everyday users? Well, Triforce currently outputs audio in mono, which simplifies things, but also means that for those craving a stereo experience, this might not yet hit the mark. Think of it as a work in progress, a step in the right direction toward improving how our devices listen to us. As we wrap up, it's clear that Triforce represents a significant effort to enhance the audio capabilities of our Apple laptops, even if it's still building toward that ideal. There's so much potential here, and with community engagement, who knows how much further it can go. Reflecting on today's discussion, how do you think advancements like Triforce could change the way we interact with our devices? It really opens up questions about the future of audio technology and how it will shape our daily experiences. Thanks for joining us today, and be sure to tune in next time as we continue to explore the intersection of technology and our everyday lives.